Hi all. Today we are going to learn about Advanced SQL with Oracle. Topics that will be covered in this lesson are nested queries, subqueries, join tables, aggregate functions, grouping, using with clause, recursive query, view, drop and alter command. We are going to use the company database throughout this learning session. There are 6 tables in company database, namely employee, department, project dept _ locations, dependent and works _ on. Let's get started with using null in query. A null values means that unknown value, unavailable or withheld value, not applicable attribute. Each individual null value considered to be different from every other null value. SQL uses a 3-valued logic. True, false, and unknown, like maybe. Null equals null comparison is avoided. This is an example of a query to find employee with no supervisor. A nested queries, subquery, is a query within another SQL query and embedded within the where clause. A subquery is used to return data that will be used in the main query as a condition to further restrict the data to be retrieved. Subqueries can be used with the select, insert, update, and delete statements, along with the operators like equal to, less than, greater than or equal, less than or equal, in, between, exist, not exist, any, all and etc. Rules of nested queries. Enclose nested queries in parenthesis. Place subqueries on the right side of the comparison condition for readability. However, the subquery can appear on either side of the comparison operator. Use single row operators with single row subqueries and multiple row operators with multiple row subqueries. A single row subquery is one that returns one row from the inner select statement. This type of subquery uses a single row operator. The slide gives a list of single row operator. A select statement can be considered as a query block. The example in the slide displays the employees who do the same job as Taylor but earn salary more than him. The example consists of 3 query block, the outer query and 2 inner queries. The inner queries block are executed first, producing the query results SA_rep and 8600, respectively. The outer query block is then processes and uses the values that were returned by the inner queries to complete its search conditions. Both inner queries return single values, so this SQL statement is called a single row subquery. Subqueries that return more than one row are called multiple row subquery. You use a multiple row operator, instead of a single row operator, with a multiple row subquery. The multiple row operator expects one or more values. The slide shows an example of multiple row nested queries using the in operator to find all project number where Wong is the manager. This is another example of a multiple rows nested queries using tuples of values in comparisons. The values tuple comparison must be placed in parenthesis. The The any operator, and its synonym, the sum operator, compare a value to each value returned by a subquery. The any operator evaluates to false if the query returns no rows. The all operator compares a value to every value returned by a subquery. The any operator evaluates to true if the query returns no rows. The not operator can be used within any and all operators. Both operators must be preceded by equal to, not equal to, greater than, less than, or equal to, greater than or equal to. Compares a value to every value in a list by a query. The slide shows an example of multiple row nested query using the all and any. The all operator is used to retrieve all employees that have the salary greater than the maximum salary of all employees in Department 5. The any operator is used to retrieve all employees that have the salary greater than any employees in Department 5. To avoid potential errors and ambiguities, you are encouraged to use table aliases for all tables referenced in a query. The exists operator is a Boolean operator that returns either true or false. The exists operator is often used with a subquery to test for the existence of rows. The distinct function returns true if there are no duplicate tuples in the result of query Q. The slide shows an example of a query using the exist operator to retrieve all employees who has dependent and also a manager. Minus operator is used to return all rows in the first select statement that are not returned by the second select statement. Each select statement will define a dataset. The minus operator will retrieve all records from the first dataset and then remove from the results all records from the second dataset. The query as shown in the slide is equivalent to double negation. To list the names of those employees for whom there does not exist in a project managed by Department 5 they do not work on. This is another example of a query using the in, exist and not exist operators. To list the names of those employees for whom there does not exist in a project managed by Department 5 and they do work for. You can rename columns or attributes in SQL by using column qualifier as shown in the slide. Two or more object tables might contain columns with the same name. One reason for qualifying a column name is to designate the table from which the column comes. Join tables using join clause. Permits users to specify a table resulting from a join operation in the from clause of a query. There are different types of join. Natural join and various types of outer joins, such as left, right and full. The natural join is based on all the columns in the two tables that have the same name and data types. The join creates, by using the natural join keywords. It selects rows from the two tables that have equal values in all matched columns. When specifying columns that are involved in the natural join, do not qualify the column name with a table name or table alias. This is an example of a query using the natural join to join two tables, locations and countries. Both tables have the country _ID attribute with the same name and data type. Inner join versus outer join is the default type of join in a joined table. Tuple is included in the result only if a matching tuple exists in the other relation. For the left outer join, every tuple in left table must appear in result. If no matching tuple found, the null values will be padded for attributes of the right table. For the right outer join, every tuple in right table must appear in result. If no matching tuple found, the null values will be padded for attributes of the left table. This is the example of a query using the left outer join to join table employee with employee table. The first employee table refers to the ordinary employee or staff, called as T1. And the second employee table refers to the supervisor, called as T2. In case a row in the T1 table does not have any matching row in the T2 table, the query combines column values from the row in the T1 table with a null value for each column in the right table that appears in the select clause. This is the example of a query using the right outer join to join table employee with employee table. The first employee table refers to the ordinary employee or staff, called as T1. And the second employee table refers to the supervisor, called as T2. In case a row in the T2 table does not match any row in the T1 table, the columns values from the row of the T2 table are combined with a null value for each column of the row from the T1 table to make the result row, which is then also included in the result set. This is the example of a query using the full outer join to join table employee with employee table. The first employee table refers to the ordinary employee or staff, called as T1. And the second employee table refers to the supervisor, called as T2. If a row from T1 table does not have any matching row from the T2 table, the full outer join will include columns from the T1 table with null values for all columns from the T2 table. Similarly, if a row in the T2 table that does not have a matching row in the T1 table, the full outer join will include columns from T2 table with the null values for the columns in the T1 table. The aggregate functions is used to summarize information from multiple tuples into a single tuple summary. Built-in aggregate functions such as count, sum, max, min, and average. Grouping is used to create subgroups of tuples before summarizing. To select entire groups, having clause is used. Aggregate functions can be used in the select clause or in a having clause. We can rename the result of aggregation using the column alias or qualifier as shown in the slide. Null values are discarded when aggregate functions are applied to a particular column. The slide shows the example of a query to find the sum of the salaries of all employees of the research department as well as the maximum salary, and the average salary in this department. The slide shows an example of a query to retrieve the total number of employees in the research department using count function. The group by clause partition relation into subsets of tuples based on grouping attribute, S, and apply function to each such group independently. The group by clause specifies the grouping attributes. The count, asterisk, function counts the number of rows in the group. If the grouping attribute has null as a possible value, then a separate group is created for the null value, example, null DNO in the above query. Group by may be applied to the result of a join. The having clause provides a condition to select or reject an entire group. For example, for each project on which more than 2 employees work, retrieve the project number, the project name, and the number of employees who work on the project. The slide shows how we can combine the where and the having clause in a query. Consider the query. We want to count the total number of employees whose salaries exceed $40,000 in each department, but only for departments that have more than 2 employees work. The right query is the correct one to find the query. The with clause allows a user to define a table that will only be used in a particular query, not available in all SQL implementations. Used for convenience to create a temporary view and use that immediately in a query. Allows a more straightforward way of looking a step-by-step query. Oracle also has a case construct, used when a value can be different based on certain conditions. Can be used in any part of an query where a value is expected. Applicable when querying, inserting or updating tuples. The example shows that employees are receiving different raises in different departments. A recursive subquery factoring clause must contain 2 query blocks combined by a union or set operator. It can be made up of 1 or more query blocks combined by the union or union, intersect or minus set operators. The second query block is known as the recursive member, which must reference the query name once. An example of a recursive relationship between tuples of the same type is the relationship between an employee and a supervisor. This relationship is described by the foreign key super_SSN of the employee relation. The slides show an example of a recursive query named org_chart. To complete the query you need to union all the base and recursive queries together. Put this all together and you get semantic constraints. The following are beyond the scope of the ER and relational model. Create assertion, not supported in Oracle. Specify additional types of constraints outside scope of built-in relational model constraints. Create trigger. Specify automatic actions that database system will perform when certain events and conditions occur. Create trigger statement is used to monitor the database. Typical trigger has 3 components which make it a rule for an active database. Event, S. Condition, and the slide shows an example of trigger to capture the salary violation rule, salary greater than the manager. There are 3 components of triggers. The event, S, specified that it will be occurred during the after update of a transaction. The specific condition is, if the salary greater than the supervisor salary. and the action is to insert the SSN info, supervisor's SSN and the new salary into violation_salary table. View is a single table derived from other tables called the defining tables. View considered to be a virtual table that is not necessarily populated. Create view command. Give table name, list of attribute names, and a query to specify the contents of the view. Once a view is defined, SQL queries can use the view relation in the from clause. View is always up to date. The slides show two examples of view. In V1, attributes retain the names from base tables. In V2, we can drop the created view using the drop view command as shown in the slide. Drop view followed by the view name. There are two strategies of how to deal with complex query using view. The first strategy is through query modification approach. In this approach, the view is computed as and when needed and not stored permanently. The view query is modified into a query on underlying base tables. However, it is time-consuming to execute complex queries. Strategy 2 is through view materialization. It physically creates a temporary view table when the view is first queried. Keep that table on the assumption that other queries on the view will follow. Requires efficient strategy for automatically updating the view table when the base tables are updated. Incremental update strategy for materialized views. DBMS determines what new tuples must be inserted, deleted, or modified in a materialized view table. This is the basic syntax of how to create the materialized view. This is some basic comparison between view and materialized view. Update on a view defined on a single table without any aggregate functions. Can be mapped to an update on underlying base table. It is possible if the primary key is preserved in the view. Update is not permitted on aggregate views as the example shown in the slide. View involving joins. Often not possible for DBMS to determine which of the updates is intended. Clause with check option must be added at the end of the view definition if a view is to be updated to make sure that tuples being updated stay in the view. Inline view. Defined in the from clause of an SQL query, for example, we saw it's used in the with example. How to drop column. First, indicate the table and its schema that you want to drop after the drop table clause. If you don't specify the schema name explicitly, the statement assumes that you are removing the table from your own schema. Second, Specify cascade constraints clause to remove all referential integrity constraints which refer to primary and unique keys in the table. In case such referential integrity constraints exist and you don't use this clause, Oracle returns an error and stops removing the table. Third, specify purge clause if you want to drop the table and release the space associated with it at once. By using the purge clause, Oracle will not place the table and its dependent objects into the recycle bin. Views can be used to hide certain attributes or tuples from unauthorized users. For example, for a user who is only allowed to see employee information for those who work for Department 5, he may only access the view dept 5 emp. Create view dept 5 emp as select asterisk from employee, where DNO equals. The alter table command is used to alter / modify column in a table. Alter table actions include adding or dropping a column, attribute, changing a column definition, adding or dropping table constraints. The example shows in the slide is the alter command to include a new column name job in the employee table name. This is the examples of how to change the column definition. This slide shows two examples of alter command to add and drop constraint in employee table. In this lesson, we have learned that covered complex SQL, nested queries, join tables, in the from clause, outer joins, aggregate functions, grouping, handling semantic constraints with create assertion and create trigger, create view statement and materialization strategies, schema modification for the DBAs using alter table, add and drop column, alter constraint, etc.